Hello and welcome to Mechanical Y. Here I have a deadly laser blaster. It is a super lightweight and easy to use weapon. You just pull the trigger and woe be unto whatever you're pointing it at, right? Well, about now you're probably wondering what I'm doing. This is just a toy and laser blasters aren't real. Well, that is almost correct, and that brings us to the subject of this video. Energy weapons do exist, but why aren't they really used on the battlefield? Before we continue, let's define what we mean by energy weapon. For our purposes here, the definition will be pretty broad. We will consider anything to be an energy weapon if it uses electric potential energy to deliver an impulse. In other words, energy weapon that is a battery or generator powered. So how much of an impulse needs to be delivered? Well, let's look at a common round carried by a soldier today. This is a 5.56 by 45 millimeter NATO round. It contains a projectile which is propelled by a chemical propellant housed in this metal casing. When fired, this round is able to impart about 1800 joules of energy to the projectile, measured at the muzzle of the weapon. Now let's look at this standard AA size alkaline battery. This battery contains about 9,000 joules of energy, meaning that if I could harness all the energy that it contains, that is equivalent to firing 5 of these rounds. At first glance, it looks pretty promising for the energy weapon idea. You can tell that these two are about the same size, yet this one can fire 4 more times than this one can. But let's go through some of the obstacles in using energy weapons that may not be obvious. First, there is efficiency. This battery can deliver the energy of 5 of these rounds only if I can harness all of the energy in the battery. But let's measure energy efficiency as a ratio of the amount of energy that is delivered in the impulse to the energy required from the battery. Realistically, how much can be utilized? We start with energy weapons that have actually been built and tested. A coil gun, also known as a Gauss gun or Gauss rifle, uses electric fields generated by coiled wires to accelerate a projectile. In theory, they behave like a linear motor, so efficiencies of 80% are actually plausible. In practice, efficiencies of only around 20% though have been achieved. Now it's not looking so good for the battery. But let's look at other energy weapons. A railgun accelerates a projectile between 2 electrically charged rails, using what is called the Lorentz force. According to military studies, these have an efficiency of about 40%, better than coil guns, but still not great. Moving on to lasers, we can look at what is called the slope efficiency to see how well they can convert the energy in the battery to damage downrange. Like the railgun, they also output about 40% of the battery's energy. Other energy weapons like plasma guns or blasters have not really been demonstrated to be possible, so we'll not consider them here. Nevertheless, energy weapons still look pretty good. That is until we get to the second issue. Now let's look at energy density. A soldier would have to carry these into battle. How much of each of these can one carry in comparison to each of these? As it turns out, this complete round has a mass of about 12.3 grams. This battery alone weighs 24 grams without any projectiles included, which means that I can carry 2 of these for every one of these. So now this comparison is more realistic. And now it's a dead heat. But alkaline batteries are not our best battery. What if this was an energy-dense lithium battery? Wouldn't the weight go down significantly and we'd be able to fire it many more times for the same weight? The short answer is yes, but this comes to the third main issue: materials and resources. This round is made up of cheap and easy to work with metals like brass, copper, and lead. The propellant is made from easily obtainable ingredients that contain elements like nitrogen, oxygen, and carbon. Furthermore, this round is fired and all of the components of it are typically discarded. You can't really afford to discard any kind of battery regularly on the battlefield. Lithium is not as inexpensive, easy to work with, or as available as any of these metals are, especially not the more energy-dense battery formulations that we can come up with. So in the end, when considering impulse, energy density, and material used, energy weapons can at best only match current technology. But there are a number of other smaller issues that this simple round also solves. This round is quite durable and self-contained, much more so than the batteries can get. When fired, the ejecting casing absorbs and carries away excess heat, helping to keep the weapon cool. That is not true about batteries. And the weapon that is used to fire this round can be made very robust and very durable. So in the end, are we ever going to see energy weapons on the battlefield? Well, as it turns out, we are. Militaries are already developing them. Though there are major shortcomings with current technology, there are several key advantages that are so desired that makes all the shortcomings worth it. For instance, a railgun can easily fire projectile at speeds 2 to 3 times faster than this round can. Furthermore, many of the shortcomings are not insurmountable. Efficiencies can be improved. Different materials and battery formulations can be used to increase energy density and decrease cost. And why do we even need to use a battery at all? We may be able to develop super lightweight energy generators or power packs that make these obsolete. I have no doubt that this can and will happen in the near future. We just aren't quite there yet. Well, thank you for watching. I hope you found this interesting. If you did, please like and share this video, and please subscribe to stay up to date on new content. Also, visit us at our website, www.mechanical-y.com.